Equilibrium of a particle. Equilibrium of a particle in mechanics refers to the situation when the net external force on the particle is zero. According to the first law, this means that the particle is either at rest or in uniform motion. If two forces F1 and F2 act on a particle, equilibrium requires F1 equals minus F2. That is, the two forces on the particle must be equal and opposite. Equilibrium under three concurrent forces F1, F2 and F3 requires that the vector sum of the three forces is 0. That is, F1 plus F2 plus F3 equals 0. Figure 5.7 Equilibrium under concurrent forces. In other words, the resultant of any two forces, say F1 and F2, obtained by the parallelogram law of forces must be equal and opposite to the third force F3. As seen in figure 5.7, the three forces in equilibrium can be represented by the sides of triangle with the vector arrows taken in the same sense. The result can be generalized to any number of forces. A particle is in equilibrium under the action of forces F1, F2 till Fn if they can be represented by the sides of a closed n-sided polygon with arrows directed in the same sense. Equation 5.11 implies that F1x plus F2x plus F3x equals 0, F1y plus F2y plus F3y equals 0, F1z plus F2z plus F3z equals 0, where F1x, F1y and F1z are the components of F1 along x, y and z directions respectively.